I will shortly discuss how there are two main objectives one may be engaging in when working with data visualization. Either you're trying to learn something from your data, or you already have an insight and need to effectively or persuasively communicate that insight to other stakeholders. In either case, it's important to know what type of visualization is best suited given your data or your analysis. As we enter the last unit of the course, the end is now in sight, and I think that it's time to again return to our AMPS model of data analytics, which I said would serve as a roadmap for what we do. We began this course with a discussion about how to develop a high-quality line of questioning. We focused on issues that were measurable, actionable, relevant, and within an appropriate scope of analysis. We proceeded to learn a variety of skills to help us master data in Excel. All the functions and formulas we learned will help you perform useful transformations on data you encounter in Excel. But then we broadened our scope, and our tool of choice became Power Query, where we learned how to automate the ETL process. And we continued to master the data by learning data profiling, data filtering, structuring, and combining. We concluded the second unit by touching on the Perform the Analysis step. This involved a brief introduction of how accountants may apply statistical techniques in their work. But in this final unit, our focus will be entirely on data visualization, which forms part of both of these final two steps of the AMPS model. But what is data visualization? Well, I think the term is sufficiently straightforward that you probably already have an idea of what it is. We're taking some data and we'll use pictures to make the content more digestible. As humans, we have limitations. We can't take a dataset with millions of records and immediately process relationships and comparisons. We use visualizations to quickly and effectively summarize and communicate insights from the data. And I'm going to argue that there are two primary reasons or objectives as to why a data analyst will be engaged in visualization activities. The first is to better understand the data. This is referred to as exploratory data visualization. In other words, one can think of visualization as an analytical technique. Sometimes this can be a structured approach where we already know what we're looking for and we can either construct a visual from scratch or simply refer to a pre-built visual in a dashboard to find what we need. But at other times it can be a very creative, unstructured approach where your objective may not yet be clearly defined and you are simply trying to acquaint yourself with the data. Ultimately, exploratory data visualization is a process of learning. It can be used to generate or assess hypotheses, and in the end, our goal is to discover insights from the data through the visuals we construct. We can contrast this with explanatory data visualization. In this scenario, the data analyst already knows the insight, and the job is to simply construct a visual that will effectively and persuasively communicate the takeaway to an audience. Again, the key difference is whether you already know the insight. And the reason for making a distinction between these two types of objectives is to help you realize that the activities we engage in for either approach will differ based on what the objective is, either to learn or to communicate. Relating this back to the AMPS model, we could also describe this distinction as which step of the framework we happen to be in. We would classify exploratory data visualization as an activity in the Perform the Analysis step, whereas explanatory visualization falls under the Share the Story step. The first thing to square away is knowing how to select which type of visualization we need to construct that is best for the job. We need to take into account the type of data in question, the type of analysis we're trying to conduct, and this informs which type of visual to build. Just like you would prefer to use a hammer to pound in a nail, you'll want to be sure that, given your data, you employ the correct type of visualization to drive a point home. And there are a lot of different tools out there. For now, we're going to discuss very basic approaches that are tailored to specific objectives. We'll start with categorical data. This refers to data whose primary function is to designate different groups. And there are all sorts of groups we might care about. Product lines, customer demographics, geographical segments, payment methods, departments, the list could go on and on. And the reason why an organization is bothering to keep track of this categorical data is likely because it wants to compare outcomes across groups. When you're dealing with a single point in time and you have several groups you want to compare across, bar charts are best suited to illustrating that comparison. Say I run a balloon business. I know I want to sell balloons, and I have a rough idea of how well different products sell, but I could use data to specifically track the color of balloons sold in every transaction. This column in my data set reflects categorical data. I could thus graph the frequency of sales of each color in a bar chart, and this helps me quickly identify that blue seems to be the most popular color, black not so much. So to review, categorical data designates different group characteristics or categories. If you want to quickly facilitate comparison across these groups, as of a single point in time, bar charts are your best bet. Next, we have univariate data analyses. These rely on a single column of numeric data, and our aim is to better understand the distributional properties. Now, we can of course just calculate descriptive statistics, that's easy to do, but often a visual provides the most immediate story of a variable. Typically, the best type of chart for this type of analysis is a histogram. As an educator, I'm always interested in seeing how my students perform on their assessments. So to understand the distribution of scores, Canvas will provide me with a histogram to review. And just so you know, these scores come from an exam I gave at a prior institution. This histogram tells me a few things above and beyond numeric statistics. For instance, the average score on the exam was roughly 81%, but I can quickly see that most of my students actually scored above that average. The mean was skewed left by a few outliers in the 60s range. And I can also see that this distribution is bimodal. In other words, two scores were most common, perfect scores and a column that's more in the B range. And overall, this histogram gives me a sense of how my students did and how I would need to calibrate the difficulty of the exam going forward. Multivariate data involves multiple variables, and the purpose of multivariate data analyses is to examine relationships and correlations between variables. With multiple linear regression, we were able to assess correlations with several independent variables. But when it comes time for visualization, these types of relationships are typically only illustrated between two variables at a time. For these types of analyses, scatter plots are ideal for showing relationships between two variables. For instance, if you want to examine the relation between a cost driver and overhead expenses, a scatter plot will help demonstrate whether a correlation exists. Even the regression line that you see here is a form of data visualization to help illustrate how costs respond to a given cost driver. When data points are repeatedly collected within a unit over time, we call this time series data. And since we're looking within unit over time, our aim is to assess trends. We want to see how outcomes emerged historically, and this can give us an idea of what will happen in the future. If you're working with more than 2 data points over time, I would strongly urge you to use a line chart to convey time series data. Hands down, line charts do the best job at displaying trends, including seasonal trends like you might see in sales figures. The last type of visual we'll consider in this video involves proportional data, which reflects parts of a whole, such as percentages or fractions. We want to see the frequency of a response relative to all other responses. The first type of visual that relates to proportional data is a pie chart. Now you've got to be careful with these. Many data visualization experts will tell you that there is never a good time to use a pie chart. And even those who are more open to using them still offer a bunch of caveats as to their use. So one immediate takeaway here is, usually a safe approach is to simply avoid using pie charts if you're familiar with alternative ways of presenting these types of takeaways. And one potential alternative is a 100% stacked bar chart. For a given bar, its totality equals 100% of all outcomes, and the relative proportion of a given category is represented as the associated fraction of the bar. There are also pitfalls with these types of visualizations, and we will discuss best practices for all of these types of visualizations later. But for now, we can just take note that these are 2 types of visuals specifically designed to accommodate the presentation of proportional data. So to recap, let's remember that there are 2 main objectives when we're engaged in data visualization. With exploratory visualization, we are trying to learn something from the data to better acquaint ourselves with it and discover insights. With explanatory data visualization, we as the data analyst already know the insight, and our focus is on effectively and efficiently communicating that insight to stakeholders. The other main takeaway to be aware of is you've got to know the different types of categories of data and which charts are most appropriate given those analyses.